The per VLAN spanning tree, which is there running by default, is a modified version of IEEE 802.1d. This per VLAN spanning tree is Cisco's, and that's the default. When you go here and type show spanning tree, you can see for each VLAN a separate database. For VLAN 1, it says the priority is this 32768, the default one, and then the VLAN ID together it is 32769, and if you see here, there is only two interfaces because we don't have any computers in VLAN 1. But when you go back to the same show command and go down, you can see for VLAN 10 there are three interfaces because we have used F01 to connect to a computer which is in VLAN 10, and F02, that is F01 in VLAN 10 and F02 in VLAN 172. And these two are trunk ports. Whereas for VLAN 1, you see only those trunk ports. You don't see any members. This shows that there is a separate instance of the spanning tree. And it is a modified version of IEEE 802.1d. You can also type like this: show spanning tree VLAN 172 if you want to see only that instant output. You also have detail command. Okay, not in this packet tracer in the real device. You have a detail command that will also give you some elaborate information of what you see here. And this portion is always talking about the root switch information, not the switch which you are in. But the switch, because it is also a root switch, you see just the same copy. This one here, and then 32768 plus 172 is 32940. I'm sorry. So, what else we see here? Now, why is this root switch? It is because of the MAC address 007, whereas the other switches they have something bigger. Now, let's copy the MAC address and put on the board. Switch. You can copy any one of the MAC address 07 E8 EC8411 8C. It's going to be the same for all VLANs. One switch will have only one MAC address, whereas the router port, each port will have a MAC address, dedicated MAC address. Okay, so now for this switch, what's the MAC address? Show spanning tree, and this is down. This one is the last. Done. Now, when you compare these MAC addresses, you will be very clear why Which one is the root switch? Now, what are we going to do is manual load sharing. That's the reason why we keep per VLAN spanning tree, so that for some VLAN, the preferred path will be upper path and blocking in the below path, and for the other VLANs, forwarding path will be the below path and blocking path will be the upper. Right now, this port F04 is blocking on switch 4 for all VLANs. I'd like to show you before we move further. Now, show spanning tree for VLAN 10. You see a block for VLAN 10 F04 and VLAN 172. Again, F04 is blocking. That proves that all the traffics are going via the upper path. All the traffics are going via the upper path. Let's do the load sharing. What I'm going to do is I'm going to use the priority to do this. You see, in spanning tree, there are 16-bit for VLAN priority marking. In that 16-bit, you know about VLANs, it's 4096, which is 12-bit. So the higher order 4-bit, which is 2 to the power of 15 and 2 to the power of 12. This is what given for priority. From 2 to the power of 0 to 2 to the power of 11 is VLAN. So totally 16-bit, right from 0 we start. Now, this is 2 to the power of 12, 4096, which means the sum of all these face value will give you 4095. That many VLANs you can have. That's for VLAN reservation. So from here, only from this bit it is given for priority. So if you are setting priority, you cannot use any number between 0 to 4095. Why? Because they are for VLAN. You cannot say, I want to set priority 100. No, you can't set priority 100. For priority, it is only from 2 to the power of 12 it is given. So if you want to give priority, it should be 0, which means you can use 0, which means all these bits are 0. 2 to the power of 11, 2 to the power of 13, 2 to the power of 14. 0, priority 0 means what? All these 4 bits are 0. And what is the default? Default is 1 here. 1, 0, 0, 0. That's why you have what? 32768. Your calculator. You see 2 to the power of 15 is 32768. Because this bit is turned on, you have the default priority as 32768. But when you make this bit also 0, then the priority becomes 0. The default is 1, you're making as 0. And now you can also put 1 here After 0, this is the lowest. When you put 1 here, what's the value? 4096. And if you put 1 here, what is the value? Just doubles, right? 8192. So it's in the multiples of, it's in the increment of 4096. Increment of 4096. That's the base number. 0 after that 4096. Okay. Now let us go and try giving priority here. This is the plan. I'm going to say for VLAN 10, priority is 0. For VLAN 172, priority is 4096. And on this switch, I'm going to do the opposite. For VLAN 172, priority is 0. For VLAN 10, priority is 4096. Now, what will be which one will be the blocking port? If you see, for VLAN 10, let me copy this. For VLAN 10, this is going to be the root switch for VLAN 10. Whereas for VLAN 172, this will be the root switch. Because smaller the priority, more weightage. If this is the root switch for VLAN 10, forwarding. And now this is the root port for VLAN 10. Root port, because this is the low cost part. And now this switch will see whether to take this as the root port or this as the root port, because the cost is same. Here also 19, here also 19. And this way also it is 1919. Because the path cost is same, then what it will do, it will see which neighbor has got the lowest MAC address. This neighbor has got lowest. So this will be the root port. This will be the blocking port. For VLAN 10, this is going to be the blocking. Let's go see that after configuring. This will be the forwarding designated. This will be designated forwarding. This will be root port. This will be BLK. That's for VLAN 10. First, let's finish for VLAN 10. On switch 2, I have to set the priority as 0 for VLAN 10. But as of now, it is 32768. I'm going to say spanning tree priority is spanning tree for VLAN 10. Priority is 0. After I do this, you will see in this switch the role change for VLAN 10. Show spanning tree for VLAN 10. Look at this. As we analyzed, as we concluded, this F02 is blocking. F02 is blocking. Now, let us do 0V as priority for 172 VLAN on the switch 3. So before we do that, let's discuss which one will be blocking. I'll write in different color for VLAN 172, maybe blue. VLAN 172, this will be forwarding, this will be forwarding because this is the root switch for VLAN 172. And this will be the root port, and this will be the root port. And this will be designated forwarding, designated forwarding. So blocking will be this place. F02, because this side is big MAC address, this side is small MAC address. This is the designated forwarding. Sorry, this is the root port of this switch. Every switch should have at least one root port. So this is the blocking port, F02, after I finish setting priority. Let's go. Switch 3. Right now, if you see show VLAN, show spanning tree, VLAN 10, it's not, sorry, not VLAN 10, 172. 172, it's not blocking. But we expect switch 2 to block. As of now, switch 2 is not blocking. That also I want to show you. You already know it, but show spanning tree for VLAN 172. It's not blocking. But after I finish configuring on switch 3, oh, so the command is spanning tree for VLAN 172 priority 0. After I finish this, I want to go to switch 2 to check whether F02 is blocking or not. It should block. Let's check. Earlier it was not blocking, but now it is blocking. So for switch for VLAN 172 it is blocking, whereas for VLAN 10 it should not block. It is forwarding. So that proves that the traffics are load balanced. So when you ping from VLAN 10 PC, your traffic is going to go via the upper path. Ping from 172 VLAN PC, it is going to go via switch 3 to reach 172.16.02 from 116.01. Now, what is next is the backup. If in case the upper path goes down, the VLAN 10 root switch, I want it to be switch 3. I don't want any other switch to become a root switch. So what I do is, for VLAN 10, I gave 4096, so that if that current root switch, if that switch 2 goes down, I want only this to be a root switch. Okay. Yeah. So let us go to switch 2 and make that as a backup for VLAN 172. And we'll go to switch 3 and make it as a backup for VLAN 10. Let's start from switch 3. Switch 3 needs to be a backup for VLAN 10. VLAN 10. So I say spanning tree, priority for VLAN 10, priority. Look at this. If I say priority 500, it won't accept. It says it should be the increment value of 4096. All right, so I'm going to say, you know the reason why. I have already explained you. 96 for VLAN 10. And let's verify that. Show spanning tree for VLAN 10. You can see the priority is 4096 plus 10, 4106. Whereas for VLAN 172, priority is 0 plus VLAN number Priority is 172. It's the opposite on the other switch 2. We will configure backup. For VLAN 172, we'll put priority 4096. Okay, what is next we want to verify? We want to see whether the backup happens or not. Right now, switch 2 says show spanning tree for VLAN 10. I'm the root switch. Oh no, VLAN 10. It says I'm the root switch. Switch 3 is not saying that. Switch 3 for VLAN 10, it's not saying I'm root. But when you go and disturb switch 2, I'm going to do what? Shut down a port. Interface F0/2. Shut down. And now you will see switch 3 claiming that root switch role because this is the next biggest priority after 0. Give some time. This is not a rapid spanning tree. It will take time. You see, it's in a listening state. It has to listen to BPDU to come to a conclusion. Now, okay, why this is still... According to the priority, this should take the role of root switch. That's what I'm waiting for. Oh, there is another interface, so it is still... Actually, it is the switch should go down completely. I just shut down one of the port. That is why this happens. I have to shut down both, which is equal to switch going down. Because this has got still the VLAN 10 active. One of the interfaces, a member, the trunk. It won't give up the role. But the port has got forwarded there. The blocking is no more. But the root switch role is still with this switch because there's some members again available. The entire switch has not gone down. So I'm going to shut down the port interface F01. Shut up. Okay, now the BPDUs will go and make the difference. Earlier this was like this. Now give some time for the BPDU to work. Did I shut down? Yeah. Okay. Because the interest. Okay. Oh yeah. Look at this. It took some time for the BPDUs to reach. So switch 3 has become a root. Now, if I bring the ports back, it should go back. Again, after negotiation, it should go back. Interface F range F0/1-2. Switch port, no shutdown. Okay. I'm expecting this to become a root switch again. And switch 3 will give up the role for VLAN 10 alone. This won't be there if I check now. Gone. But for VLAN 172, it should be the same. Okay, it's still the root switch. Now going to switch 2 to check it, show spanning tree for VLAN 10. You can see this is the root switch. But for VLAN 172, this is not. So failover backup path is guaranteed because you have put the priority, it is the guaranteed path. If you have multiple paths, we got only two paths. If you have multiple paths, you know which will be the backup path because you have set the priority manually. That's the advantage of setting priority manually. Right. Now, the next is the rapid spanning tree. See, enabling rapid spanning tree is easy. Hold on. Before that, I have something more to tell about priority. I'll cancel these priorities which I configured. What we have seen is setting priority manually. There is also an option. You no need to set manually. You can also use a command and the command will set it. Wait a minute. Okay. So what we are going to learn is instead of giving priority number, you can just put command. There's a command called root primary, root secondary. So we are going to use that command and see how the priority changes. Priority will change as per the command. You see, I'll say here, this is spanning tree for VLAN 10, root primary, spanning tree for VLAN 172. Let's put it in another color. VLAN 172 root secondary. Whereas here, spanning tree for VLAN 172 root primary, spanning tree for VLAN 10 root secondary. This is what we're going to do. When we do, what happens? When you say primary, from the default 32768, 4096 will be deducted. When you say secondary, from 32768, 8192 will be deducted. No, I'm saying the opposite. When you say primary, 8192 will be deducted. When you say secondary, only 4096 will be deducted. Now tell me, in this switch, for which VLAN the priority will be small? When you say primary, yeah. When you say primary, 8192 is subtracted. But when you say secondary, it's only 4096 is separated. So for VLAN 10, switch 2 will be the root switch. For VLAN 172, switch 3 will be the root switch. Because here 172 has got the primary, bigger number is subtracted, so you will get small answer. Let's use the calculator to know the number. From 32768, I subtract 8192. And I get 24594. 24594. Which means for VLAN 10, it's going to be 24594 here. Here for 172, 24594. And if it is secondary, it's going to be 32768 minus 4096. You get 28672. 28672. This is for VLAN 10 here, and this is for VLAN 172. 28672. Let's go and verify this after configure. First, let me configure. I'm on switch 2. Right now, if you see, show VLAN, show spanning tree VLAN 10, it's default 32768. But when I say spanning tree for VLAN 10, root command, not the priority command, root primary. And spanning tree VLAN 20, root second, sorry, not 20, VLAN 172, root secondary. Going to the other switch, we do the opposite. On switch 2, spanning tree for VLAN 172, root primary. Spanning tree for VLAN 10, root secondary. Now, I'm going to show you the output on switch 3. In switch 3, this is what we were discussing. In switch 3, I want to see for VLAN 10, 28672. Switch 3. Show spanning tree for VLAN 10. You see 28672. And for VLAN 172, it will be much smaller than this, and it is root switch 24576. You see 24576. 24576, not 4. 6. Did I do any subtraction mistake? Yeah, 8 minus 2 is 6. 4. So this is another way of making root switch. You can give directly the priority numbers. If you are confused whether to increase with 4096 or if you don't know, you can use this root primary secondary command. Okay, what is next? Next is we are moving on to this rapid spanning tree. You see this rapid spanning tree, one single command only, simple. Already we have seen load balancing. This load balancing is applicable for rapid spanning tree also. We already set the priority. But we want it to be faster. When I go here and put this command, show spanning tree for VLAN 10, I see IEEE means 802.1d's extended version is what this pervaliant spanning tree. Let me make it as rapid now. Spanning tree mode rapid. That's it. Very simple. For each VLAN, a fast spanning tree is enabled. Now, if you go and check show spanning tree, it shows RSTP. RSTP is enabled. Let's enable on all other switches. Spanning tree mode rapid. Spanning tree mode rapid. Spanning tree mode rapid. The protocol is rapid, that's true, but this is not enough for fast conversion. See, for example, VLAN 10 is going on the top, we know it. Because show spanning tree VLAN 10, this is the root. Let's ping. Sorry. Ping -t 10002. It's pinging. As it is pinging, I'm going to cut the wire. And right now this is blocking for VLAN 10. The below switch shows spanning tree for VLAN 10. It's blocking. Now, when I cut the wire there, the proposal will fly. I'm going to cut the wire like this. Shut down. Interface F0/1. Now, if you see here, earlier it was blocking. Even now it is blocking. You see, it should have immediately, less than a second, it should have changed to forwarding. Why it is still not forwarding? We are going to learn something. So it's not a mistake of rapid spanning tree. It's the BPDU. All right. Let us now learn port fast. Port fast is the problem. The ports are not fast. Let me bring the port back. Right. So the port was not really coming up. There was a lot of blocks. Though I have enabled rapid spanning tree, it didn't work. All that we learned is correct, but along with it, we also should learn this. Whenever you will enable rapid spanning tree, you need to make sure these ports that are connecting to the end devices should not be considered for the port role. You see, this blocking should become forwarding. That's what we were expecting. But the problem is, as soon as this link went down, this guy has to send a proposal. But this guy is not sending. Why? When something goes wrong, immediately the topology change notification will be flooded, for which this switch will respond, but these PCs won't respond. Will PC respond to BPDU? No response. The change, the changed version of BPD goes to this guy, and this guy should confirm, yes, I agree, I accept the proposal, something like that. But these guys are not sending. As a result, the switches need to wait for the role change until they get the response from all the agreed agreement from all switches, all devices. They have to wait. They have to wait for the agreement from all. But this species cannot agree for the proposal because they don't understand BPD. So we are going to enable port fast on these ports so that for the proposal, they no need to agree. You don't need to wait for them to agree. You don't need to wait. That's what called as port fast. You don't need to expect them to respond when the topology change happens. Port fast. Let's go enable port fast on all the host ports. F02 on switch 1 and switch 4. F01 and 2 on switch 1 and switch 4. Interface range F0/1-2 switch port more or switch port fast. No. Spanning tree port fast. That's it. You should not enable this on a non-trunking. You should enable only on the non-trunking port, not on the trunk ports. Now, you should not enable this between the switches and concentrators. Meaning, you should not cancel that here. You can cancel here. That's what the message means. Let's do it again here. Interface F0/2 spanning tree port fast. Right, we have enabled port fast. Show spanning tree VLAN 10. We have enabled port fast on F0, 1 and 2. Now, I would like to verify now. You see, right now the ping is happening without any problem. And this 14 milliseconds is because of the port fast I configured. It got disturbed. So now this is VLAN 10 show spanning tree VLAN 10. This is the root right now. We are going to disconnect or shut down or do something to the wire so that we want this switch 3 to become a root switch. Right now it is blocking, not root switch. We want this to become a forwarding. We want this switch to become a forwarding switch. Let's see how quickly this can forward. I'll just go and cut the wire. Instead of shutting down, I'm cutting the wire. Boom. So immediately the proposal would have gone now, and oh no. Let me put the wire back. It should not take this long. Well, let's wait. Something is missing piece. VLAN 10. Is it pinging now? It is pinging. Now, it should not be this slow. Immediate. Now, let us shut down both the ports. It is equal to killing the switch. Interface range F01-2. Shut up. Boom. Now I want to show you here already forwarding. Yeah. So it should be natural. I was just shutting down one side. No, it should be a normal accident, not intentional. So if you see the lost packet, it's 2 packets. Now when I bring the port back, there is no loss. Is there a loss? Yes, there's going to be 1 packet. Okay, that's all. In the real device, it's not even this 1 packet loss, you will see. But in a large environment, yes, we do see 1 or 2 packets lost. See, it's not bad like the other spanning tree that which we learned. This is faster, less than a second. It should happen, actually speaking, tested like less than 25 millisecond convergence. We have seen that. It is not timer based. Proposal and agreement, that's all. No listening, learning again, right? So that's about the rapid spanning tree. The priority commands that you learned earlier, it's the same story for this, so no need to do it again. Priorities are already set. The load sharing will happen even for rapid. Now, one last protocol that we have is MST. I don't know whether MST is supported in packet tracer spanning tree mode. It's not supported. I used to teach with EV.